Hi there, this is the Science Lady doing grade 11 and 12 physics. Today's topic is complete summary of the vertical projectile motion. Vertical projectile motion is about the up and down motion of objects. For example, a ball that is thrown up or down. You first need to know the definition of a projectile. It is an object upon which the only force acting is the force of gravity. Gravitational acceleration is always downwards, whether the object moves up or down, and it has a constant value of 9.8 meters per second per second. Now, we say that an object is in free fall when the object accelerates with a constant 9.8 meters per second per second. Constant acceleration means moving faster and faster every second, covering more and more distance every second. Keep in mind the formula for acceleration is delta V over delta T. Thus, it's meters per second per second. Let's look at two illustrations. The one is the two vehicles. Car 1, the red car, accelerates towards car 2. Car 2 was traveling at a constant velocity. Car 1 catches up because car 1, the red car, was accelerating, covering therefore more and more distance every second, more so than the blue car. The other example is a falling object. As the object falls, more and more distance is covered every second. You will notice the spaces between it represents the distance. In this example, the object is not in free fall because there is air resistance present. The air resistance is a force that counteracts against the gravity force downwards. Terminal velocity is reached when the upward force, namely air resistance, equals the downward gravity force. This causes the object then to move at a constant velocity, so there is no more acceleration experienced. Jumping out an airplane with a parachute is based on this principle. When the parachute opens up, there is greater air resistance experienced, and the parachutist will shoot up for a moment and then gradually reaching terminal velocity, which means a constant acceleration will be experienced. Here I made a few drawings or sketches of possible scenarios of vertical projectile motion that you may encounter. But first let us establish something else. Acceleration, gravitational acceleration, I've chosen in this example as positive. Now by now you know that acceleration is a constant and it's therefore positive for up and down. But in the examples that I'm giving you now is, let us see what is the situation with the velocity. Now, if I throw something up against gravity or against gravitational acceleration, which is then positive, the object will then travel in a negative direction because it goes against. So in the scenarios I'm showing you here now, my blue dots is my point of references. So let's look at the first example. In the first example, this one over here, I throw an object up, and because it's away from gravitational acceleration direction, the direction for the velocity is negative. The object reaches a maximum height where the velocity will be 0, and then the object is traveling back to the point of reference over here. If we look at scenario number 2, my point of reference, again the blue dot, the object is thrown up, reaches a maximum height where it's 0 velocity, and then it falls down, but not completely to where it came from. It stops somewhere midway. The next scenario is where I start somewhere there as my point of reference. I throw the object upwards, so the direction of the velocity will be negative. The velocity will decrease, decrease, decrease up to a point where it's 0, and then it will come down past the point of reference. That was the point of reference originally, the original height, but it will travel past the point of reference to the ground. The next example is where we have an object that is thrown straight down. That's my point of reference. Let's say on a second-story building, you just drop an object and it's coming straight down. The following example is a bit tricky, but not impossible. Let's look at an example of an object that's traveling within another object. Let's say a person with a camera inside a hot air balloon. They're obviously traveling upwards. The person then drops the camera, and now this is the motion for the camera. The camera will first go up for a short while. It reaches the 0 point there again for the velocity, and then it is falling down to the ground. And then this last scenario is where the point of reference, I made a small mistake, that little blue dot should be over there. Where the point of reference is over there, it's a bouncing ball or a bouncing object. Where the object is going up, it stops, coming down, going up again with less energy, or less momentum if you like, coming down, and even less. I hope this will help. When you do calculations, you need to remember the following. Acceleration is a constant 9.8 meters per second for the up and the down motion. Velocity is always 0 at the greatest height. Time up from the point of launch equals time down to the point of launch. And displacement up from the point of launch equals the displacement down to the point of launch. Remember these. Also know that the tangent to the gradient for a displacement versus time graph indicates instantaneous velocity. So the velocity at that point over there will be called the instantaneous velocity at that point. Please know that the gradient of a velocity versus time graph equals constant acceleration. And therefore, you will find on a graph like this, the gradient in the first section here, it shows an increase in the velocity. So there's acceleration. Then the velocity is constant over there. Therefore, there will be no acceleration. Then you will have an increase in the velocity again at that point or that section. And an increase in velocity means there's acceleration. And then you have a deceleration at that negative gradient over here. A deceleration, which means the velocity decreases up to a point where the velocity is zero again. Also know that the area under a velocity versus time graph equals displacement. Because we are doing vertical projectile motion, we are talking about delta y. Here you can clearly see the areas indicated, and you can break these areas up into triangles and rectangular blocks, and then you can go and calculate the area. For a triangle it will be half base times height, and for a rectangle it will be length times breadth. The graphs for vertical projectile motion is for the following graphs: displacement time, velocity time, and acceleration time. Let us look at an increase in velocity, a decrease in velocity, and a constant velocity for each of these graphs. I give you some time to study an increase in velocity, i.e. acceleration, for three different kinds of graphs: displacement time, velocity time, and acceleration time. Please note that we indicate the direction, positive and negative, for each graph. I give you time to study this. I give you time to study the decrease in velocity, i.e. deceleration. I give you time to study constant velocity, i.e. zero acceleration, for the following graphs. When answering questions, first make a drawing and add the directions for up and down. Make sure you understand the question. When you do calculations and you've done your drawing, break the whole motion up into parts or sections and use these three equations mainly. Remember to subscribe if you want more information on the Science Lady. I hope this was helpful. And please remember to always aim for 100%. Goodbye for now.